All right, so in this video, we're going to talk about the platform framing system as a whole, and then narrow in specifically and talk about floor framing. Let's get started. Here is your textbook's illustration of a platform framing system. So it's figure 8.5, and if you want to go ahead and follow along, please turn to page 62 in your text. Let's take a look and start at the bottom of this diagram. Right? I always like to work my way up from the soil up to the roof. So we talked last week about foundations. So you know that under this diagram, it's kind of cut off at the bottom here, under this diagram is the rest of the foundation and it's bearing down on the soil below it. So here is the top of the foundation wall or a stem wall right here. And sitting on top of that is a piece called the sill plate. It's usually a pressure-treated sill plate. Another word for it is mud sill. You can see that right here. You'll find that a lot of things in construction have multiple names, nicknames, common names. It's a little confusing, okay? So keep that in mind. There may be many different names for things. Pressure-treated sill plate right here. Okay, sitting on the sill plate is our floor framing, and that's this whole structure right here. The floor platform is bearing on that sill plate, and the weight is resting there. Okay, we're going to talk more about how that floor is constructed. The next piece that comes is right here. This is your wall framing, and it's sitting on top of the floor platform. So when you think about how this is constructed, first you build the foundation, then you build the floor platform on top of that, then you build a wall on top of that. Okay, so there's a sequence to this. All right, our wall is right here. If you have a two-story house, the next thing you're going to have is another floor platform. All right, it's just the same as the ground floor, but now we're up one level right here. And we'd have another wall right here. Okay. This is the same as the first floor wall. It's just another wall built up here. And finally, you have your roof structure built on here. Let's take a look at another illustration of the same system. This one's kind of in 3 dimensions and shows a little bit more of the house. All right, so you can see how this is all coming together. Let's start at the bottom again. Here we go. We've got our foundation wall down here. Sitting on top of that, hard to see, but it's just this single line right there. That's going to be your sill plate. On top of that floor platform is going to sit your walls. So here's your walls, and they consist of these vertical studs right here. If you have a two-story home, which we're illustrating right here, the next thing is going to be your second floor platform. Then you will have another wall on top of that. And finally, you'll have your roof framing up here. Right. I suggest that you take a look at the notes, the lecture notes that I've provided, because all of these diagrams are in them. Okay, so you can pause the video, go take a look, maybe zoom in, and because these are pretty complicated diagrams, lots of information. All right, so we're moving on to the next illustration from your textbook. We're going to talk more specifically about how that floor platform is framed. Okay, so these pieces are called the joists. Here's how you spell joist, J-O-I-S-T. Right, these are floor joists, and they're running horizontally. Okay, but the actual piece of wood is oriented vertically. If you look at this, they are tall and thin. All right, because that's the direction in which they are structurally stronger. Okay, so here are your floor joists. They have an edge joist or rim joist or band joist, 3 different words for the same thing that kind of collects them and finishes off the end over on this side. Okay. On top of the joists are your plywood subfloor right there. And you can see that it's kind of nailed to each joist below. Here's another illustration of the same thing. Here are some floor joists. In this case, they are running in this direction. We've got an edge joist or rim joist, end joist over here. Now take a look at this piece right here. You can have a hole basically in your floor. Why would you need a hole? If you're going to have a staircase come through, if you're going to have an opening in the floor for any reason, if you're going to have a hatch, there's many reasons why you would want a hole in your floor framing system. And so this is how you can frame that if you need to. Okay, here we are seeing the same floor framing system, only in this case we're looking at a section through it. Okay, this isn't a three-dimensional view, this is a two-dimensional view. We've cut through the floor and are looking sideways. So we can see each of these members right here are a floor joist, right here. And they are commonly spaced either at 12, 16, or 24 inches. 16 is probably the most common. 24 maybe for ceiling joists that people aren't going to stand on. You can get them a little bit further apart. And I want to mention, take a look at how we're drawing this. See how it's a rectangle with an X in the middle of it? That is the common way to draw a structural member. So if it's a structural wood member, it's going to have that X in the middle of it. It's an easy way to visually identify those. At the bottom here, we're seeing a ceiling for the room below. So maybe this is a second floor platform that we're looking at. That'd probably be a sheet of drywall nailed into the joists above. And above your joists, that's going to be our plywood subfloor right there. One thing this diagram is pointing out is that there's actually quite a bit of room, like empty space in your floor system. And so that's very, very common to run your pipes and wires. Let's investigate this notion of span again. So right here we have kind of a section view of a floor joist. So the span is going to be from here all the way to over here. It is as far as that joist bridges between these two supports. Your textbook has a very complicated table, 7.4 on page 46, of how far different sizes of floor joists can span. It's ridiculously complicated, and I want you to use this instead. Okay, these are some rules of thumb. Here we go. A 2x6 can span up to 10 feet. A 2x8, usually 8 to 12 feet. A 2x10, you'll want to span from 10 to 14 feet. And a 2x12 goes from roughly 12 feet to 18 feet. All right, wasn't that easy? Take a look. Go ahead and look at that table in your textbook and then refer to this one instead. All right. So we've been talking about floor joists, but it turns out there is a fairly common type of prefabricated floor joist, and that's called a TJI. A prefabricated joist is lighter and more stable than lumber. It can span longer distances, okay? It's a little bit stronger. And it's more expensive than your typical lumber. All right, but if you use less of them, it can actually be more economical as a system as a whole. So TJIs, let's take a look at what they look like out in the field. So you'll know them if you see them. They look like this. They kind of look like tiny wooden I-beams. All right, they have a top flange, they have a bottom flange, and they have a web. It's this vertical piece that holds those two together, so they look like the shape of an eye. You might also see prefabricated trusses being used for floors, especially if you need to span a longer distance. They're a little bit more common in multi-family homes rather than single-family residential. All right, and they look like this. They're flat on the top and bottom, unlike roof trusses. Roof trusses are often angled, but floor trusses are flat. So in this video, we covered a lot of material. We talked about the platform framing system in general, and then went into quite a bit of detail about the floors and how they are constructed. In the next video, we're going to move on up in the world and talk about the walls. Thanks, everyone.